Aurora, an avant display of collision between electrically charged particles and atmospheric gas molecules that embellish the polar sky. The variations in the colors are determined by the types of gas molecules that take part in collision. The aurora of different colors are not produced at the same altitude because of varying elemental abundances. For example, blue and violet colored aurora is formed at around 120 kilometers above Earth due to the relatively higher abundance of nitrogen. Let's go deep into the science and address the ultimate question. What creates the aurora and why does it shine only in the polar region? It is not surprising that the story of aurora starts from our primary source of energy, the sun. The temperature of the sun's corona is of the order of millions of degrees Celsius. At such high temperatures, collision between gas molecules are explosive, and as a result of which a stream of free electrons, protons and other highly energetic ions are burst out from the sun's atmosphere, escaping through its magnetic field. This results in a huge outburst of fast-moving clouds of plasma, what is known as coronal mass ejection. If this cloud of plasma and charged particles were to hit the Earth's surface, they would cause serious damage to all life forms on Earth. Fortunately, Earth has its innate defense mechanism against this, which is its magnetic field. When coronal mass ejection hits the Earth's magnetic field gets deflected away from it. Now, let's take a closer look at the interaction between the coronal mass ejection, Earth's magnetosphere, and the physics behind it. When the electrically charged particles enter the Earth's magnetic field, the force it experiences is proportional to the cross product of its velocity vector and the magnetic field vector. If the velocity of the particle has one of its components parallel to the magnetic field, then the trajectory of the particle will be helical. The pitch of the helix is given by the parallel component of the velocity, and the perpendicular component determines the radius. When the charged particle is spiraling in a non-uniform magnetic field, where the magnetic field is stronger at both ends, it reflects from the ends and gets trapped inside the magnetic field. The protons and electrons which get trapped inside the Earth's magnetic field forms a belt known as the Van Allen radiation belt, which loops around the Earth's north and south geomagnetic poles. When solar wind shoots the additional electrons, protons and other ions into the radiation belt, an electric field is produced in the region where electrons are normally reflected. This field eliminates the reflection and drives the electrons down into the atmosphere, where they collide and excite the atoms present in the air, causing them to emit light at different frequencies. So now, the question arises if Earth is the only planet that exhibits this phenomenon. The answer is no. Basically, all planets having its own magnetic field as well as ionosphere around it does exhibit aurora. If you ever happen to get a glimpse of aurora in the future, we are sure that you would not only appreciate its visual magnificence, but also the underlying science behind it.